All right, welcome back. We are officially on day 4 of Unit 1 Scientific Inquiry. Please, as always, make sure that you have your notes out and ready to go as you follow along with me on this video. All right, here we go. So today's aim is, what are the components of a good experiment? So when we say components, we're talking about the parts of a good experiment, or what makes up a good experiment. Okay, and when we're talking about a good experiment, we want to remember two things, okay? We want to remember the concept of validity. So what makes an experiment valid? And we also want to remember the process of the scientific method. Okay, so by the end of today's lesson, you should be able to answer, what are the components of a good experiment? So today's do now is, what is the difference between a theory and a fact? Give an example of each. So I want you to pause this video, answer that question on your own, and then press play when you're ready to review it. So what's the difference between a theory and a fact? Well, I'll start off by giving you guys an example of each. So you may have heard of two theories that are pretty well known. The first one is the theory of evolution. And you may have also heard of something called cell theory. So those are two pretty famous examples of theories. I'm also going to give you two examples of facts. So for facts, you could say something like, the sky is blue. Or you could also say, Miss Collins loves coffee. Okay, so there are two theories and two facts. But what is the difference between each of them? Well, we can infer that, or we know, it's not an inference, we know that facts are based on observations and or measurements. Okay, and we also know that theories are explanations based on evidence. So to clarify that even further, facts explain what is happening, and theories explain why something's happening. All right, so the difference between theories and facts, facts explain what is happening through observations and measurements. Theories, or really scientific theories, explain why something is happening. So it's the explanation based on evidence. Okay, if you want some more examples on the difference between theories and facts, as well as something called a law, I would recommend watching this video by the Amoeba sisters. It's only 5 minutes, so it's super short, but it gives you some good insight on theories, facts, and laws. All right, but today we've got two practice questions two practice passages that we're going to work through. These are both Regents questions, so these have been on Regents exams before. If you can answer these questions, you will absolutely ace that Regents exam in June. Okay, so let's follow along with me as we do this. Part B. I don't know what I'm saying. African violet plants are grown for their delicate, colorful flowers and furry, soft leaves. People often want to touch the leaves and brush the hairy leaves with their fingers. Growers and plant owners were concerned that this could negatively affect the plant. Of particular concern was the presence of body lotion or other skin products on the hands of persons touching the leaves. A student thought this might be the basis for a science project. He selected 2 African violet plants. 10 leaves of each of the 2 plants were brushed with a gloved hand for 30 seconds, once a day, for a period of 5 days. The difference was that the leaves of the second plant were brushed with a gloved hand that had lotion applied to the glove. Okay, so the first question is, describe the type of data that should be collected to determine if the brushing with lotion was having a negative effect on the African violet plant. So the first question we need to answer is, in order to figure out what type of data we're collecting, is what do we want to be able to prove? Okay, so the question that was being asked here is the presence of body lotion affecting the plants? So the type of data that we should collect to determine if it's having a negative effect are, let's say some examples are the color of the leaves. Okay, the growth of the plant. And you also need to specify how you're measuring that. So let's say measured in centimeters. We could also look at the amount of damage on the leaves. Okay, or the number of leaves that fell off plant. So those are a few examples. You could have said something different as well. Those are just a few examples to get you guys thinking about what is the type of data that we should be collecting in this experiment. Okay, so then what is one possible hypothesis for the experiment proposed by this student? Well, we should know by now that your hypothesis is not a question. It's a statement. And it should be written as an if-then statement. And I told you guys yesterday, if you set your hypothesis up correctly, it should read something like if IV, then DV. Okay, so in our experiment, what is our independent variable? Well, our independent variable is going to be what we're changing. Okay, and what we're changing in this experiment is the lotion, the presence of lotion. And the DV is going to be how it affects the plant. So let's say that we're going to be measuring growth. Okay, so our hypothesis would be if an African violet plant is brushed with lotion, then it will not grow as tall. Let's clarify, it will not grow as tall as those not brushed with lotion. Okay, so just to confirm, do we have our IV and DV? Well, we have our if. We also see African violet plants, which is our subject, okay? And lotion, here is our IV. We also have our then statement, and we said that growth is our DV, and I also see growth mentioned right there, okay? So when you're setting up your hypothesis, make sure you have those steps. All right, now I actually want to pause this right there before we go into the next part, and you might notice, wait, why is there a picture of a dog on Miss Collins' screen? And that's because I want to give you guys a super secret bonus question. That's beautiful. So you might be wondering, why is this a secret if she's going over it in the video? Well, that's because if you're watching this video, you'll get the answer to this question, but if you're not watching this video, then you won't know the answer to this question. And I want it to stay a secret, so don't go texting your friends, hey, did you see Miss Collins' super secret bonus question? Because it's a secret, okay? So my question today for you is, what is my dog's name? And the answer is the name of this beautiful old dog right here, who I've had for most of my life, his name is Skipper. He's the best, and I love him a lot. Now, you might be wondering, well, what do I do with this super secret bonus question? I want you to stop what you're doing right now and message me on Remind. And in that message on Remind, I want you to include the answer to this question. So all you have to do is send me a message on Remind that says Skipper. And if you send me that, I will add 1 bonus point to your exit ticket today. Okay, but as I said, this is a secret. So keep it super secret or we won't have these bonus questions anymore. Okay, moving on. Part C, deer tick. So once again, this is another passage that was on a Regents exam. So you are getting practice for the Regents as you go through these worksheets with me. All right, let's read this passage. Ticks, such as deer ticks and dog ticks, feed on the blood of humans and other animals. Part of the feeding process involves the tick injecting its saliva to help make blood flow. In the process, they sometimes spread disease organisms to their host. Sometimes ticks get on clothing and can remain there for a few days before actually biting their host. A scientist found that ticks might be able to survive even when exposed to hot water and detergent in a washing machine. Students designed the experiment below to test how well ticks survive a hot water machine cycle. Whoa, one more time. How well ticks survive a hot water washing machine cycle with detergent. Note that some of the details are incorrect. So please note that this is not a proper experiment. Many of the details here are incorrect and it's going to be our job to fix them. So our first question is identify one error in the student's design in the shaded area of the table. So we're just looking at this section down here. And explain how the student should change the experiment to correct the error. So I'm actually going to give you guys 2 errors. The first error is that if you look here at our test subjects, we see that different subjects are being tested. In the control group, we're testing a deer tick, and in the experimental group, we're testing a dog tick. That should not happen. Your control group and your experimental group should look the exact same besides the independent variable being tested. So one error is that 2 different types of ticks are used. And how can we correct that? Well, we should use the same type of tick. Okay, now a second error is actually seen right here in the number of subjects used. In the control group, we have 10 subjects, and in the experimental group, we have 100. As I just said, those should look the exact same. So we also have a different number of test subjects used. And how should we correct that? Well, we should have the same amount of test subjects in each group. Okay, number 2, explain why the student's proposed data to be collected would not likely test what the students intended. So you can find that proposed data to be collected up here at the top of this graph, where it says data to be collected. And we see that the data that the students are planning on collecting is the number of ticks surviving the cold water wash cycle. But the students intended to test if ticks can survive a hot water and detergent wash cycle in a washing machine. So if they're only collecting data about the cold water wash cycle, are they going to be able to prove if hot water and detergent affected the ticks? No. So the students' proposed data collected would not test what the students intended, because they are only collecting data about the hot water cycle, or wow, data about the cold water cycle. And because of this, they won't be able to prove their hypothesis or test their hypothesis. All right, and next up we've got identify one error with the hypothesis. So their hypothesis is, can ticks survive a hot water and detergent wash cycle in a washing machine? And I'll tell you one glaring error that I hope you picked up on is that this hypothesis is, gasp, a question. No, our hypothesis should never be a question. So hypothesis should not, no, be written as a question. It should be a statement or a prediction. Right? It should be a prediction written as a statement. All right, that is officially the end of day 4. So 2 things to do right now. Well, actually 3. You should save this, upload these notes to Google Classroom, send me a message on Remind with the super secret bonus question, and then finally, last but not least, please complete your exit ticket. This is super, super important. I need to get your exit ticket. It's actually an assessment grade, so please make sure that you guys are completing these. Fill out your first name, last name, and your answers. Okay, that is all I've got for you guys today. Make sure you submit these by 8:30 in the morning, and I will see you guys shortly. Have a wonderful day.